Hello, welcome. I wanted to make a video for people who used to work with P5.js and who are coming from that programming background and created their knowledge from there and maybe want to start with VVV. That's why I thought I'd make a tutorial, especially because I struggled in the beginning and sometimes still struggle to apply object-oriented programming from the knowledge what I gained from creative coding with processing and P5. I sometimes struggle to implement that into VVV, so I thought I'd make a tutorial which is supposed to help others, I hope, and also maybe make it clearer for me, see what my problems are there. So yeah. Also, for the people who ask themselves, why should I do VVV and do the same that I can do in P5? We maybe can do that at the end by creating some fun effects that aren't that easy in P5 unless you want to write like GLSL shaders, but there's a lot of great tools already implemented in VVV. That's why I thought it's worth it. Okay, so I would say we start with creating the class, implementing all that functionality, and then at the end we go back to the main sketch and do the rest of it. All right, then I would say let's go. Okay, so let me turn on my keyboard so you see what I'm pressing. Perfect. All right, so to create a class in VVV, we just do double left click, open the node browser and type in the name of our class, which in this case I would use it the same, so it's star, and then we scroll down and click on class. That easy. Now we have like our class, and with a middle click we can dive into that class. And on the left here we see like the class window where we can see certain properties, interfaces, operations. Most important is going to be like the operations and the properties. So what we see here in this code is we have the constructor, which is basically creating values for XYZ and PZ when the object is created. This happens in the setup here. It creates the values. Yeah, I would start with that, and then we go over to the update function, to the show function, and see what we can make happen. So to create our X value, we can type in X and scroll down to get a pad. There is the pad. Maybe we can, we could even like XPad, and then we get this, but it's called XPad. It's maybe not a good idea. So now we have this property X, but it's not defined. So we want to set a data type for it with right click, configure type. In this case, we just take a float. And we want to do the same for YZ PZ. So copy paste, another time copy paste. And then if we want to align them all, we can do Control L, but that wasn't how I wanted to align them. So we bring them a bit closer. Beautiful, almost. Now we have to rename them. So Y Z and PZ. And what we have here is we use width and height and create a random value when the object gets created. In VVV, we don't have like the direct width and height value of the window. We would have to retransform them, but we can create our own width and height and then just use that. So we would again copy to properties, type in width, type in height, and then we already have that. So we want to set the width and height as inputs. So we click on the top of the pad and hold down Control. So we created an input, and for the height the same. And now we can use these values to assign it to our other properties. So we have random minus width and width. So we would use a random from to, which we get when we click on the advanced. So it's the lower circle. We left click on it, and then we can type in random from and to float because we defined the float data type here. And then we can just connect it. And because we want minus the same value, we can negate it. So we just type in minus and then click on negate. And then we would, I'll just pull it a bit up. Then we would connect it to the from and to the to. And then we get the negative version of it and the positive. So this is grayed out now because VVV doesn't know on which operation it should create or execute this. Here we see width and height get inserted on create. And we want to do the same with this because this gets done when the constructor is called. So we left click on that link, go to assign and click on create, and it creates the connections or it colors the connections directly for us. And we want to do the same for the Y. So we again connect the Y with the random. But in this case, we obviously want the height. And again select it with Control L and align it. And then we plug in the height there and the height there. Again, right click, we also click on the on the node, and we get height. Beautiful. So we have the first two. With the width, this is a different, or with the random for Z, that's a different value. I, from my experience, would start with 20, and then we can adjust that later. So we looking for a float, doesn't call it, plug it in Z and type in 20, but we forgot the random. So what we do here now is 20 for the max, and from 0, and then we assign Z to PZ, so we can do this on create. So that's already a good start, no? So we already have the constructor. We can also hold down Alt and drag over it and write constructor. So we have this part already. Beautiful. Then I would say we go to the next one. We take care of the update. So in the update is we calculate Z by subtract speed from z. Right now we still don't have the speed value, but we can create an input for it and then do the math. So first we start by referencing z, then we take the math node. This time, if you look, we take this math node, not the negate. They're different. And then we create an input with control again and call it speed. So now it is red because we use z here, but it's got a value got saved in there, and it's all still assigned to the create operation. So we're in update now, so we have to create a new operation, and we can do that in different ways. We can go here to operation, left click, and write update. This gives it this gray color, and then we have to like right click on the node, go to assign, click on update, and it doesn't want it. So we go to the link again, click on update. I guess we have to click on the red link. No. Let's see. Doesn't want to be what it is. So let's see. We have the Z on update here. Now I would assign that again. Oh, it is. Great. Okay. So again, we have to, maybe because I copied it. So we have to, again, go to the node browser, click on Z, and now connect it. And it still doesn't want to. Let's see. Now we're talking. Okay. So the speed needed to get assigned properly to the operation, to the right operation. And now we can properly start. So we have this operation now, and now we want to check, do the if z is smaller than 1 after this calculation. So we type in if in the node browser, and we need the smaller than, so we can just click smaller. And the output of the calculation goes into left one. And the other one gets the 1. We also can make this more pretty. This. And if that's true, we want to execute what's in here. So what we want to do is we want to take the values that we defined here, and if this is smaller, we want to assign new values. Otherwise, it keeps the old values. So what we're going to do is we reference the properties x, y, x. We start with x. We plug it into to enter the region, because otherwise the changes inside the if doesn't get applied at the end. And then we can, below it, again reference z and connect the lower diamond with it. And now only if this is true, what's inside the region gets applied and saved to the value. If this is not true, the value from here just gets passed into x, and it's not changing. And we want the same which is here. We set here x value, we set here y value, so we do the same for y. So we have at least the basic structure, and after that can do what we can apply the changes if it's true. So we have x, we have y, we have z. So we need z, which comes from here. We have it again. Make this like this. It's nicer. And then we take the z that got calculated here, plug it in there. Then we can save it again if it's smaller. If not, it gets passed by. Beautiful. So what we have here is like this z equals width. So width, as I said before, is probably not the best value. We can check it later if it's okay or not, but I would just double right click if it wants that. Doesn't. So we just do, because it doesn't, we just do left click and middle click and then can create like a value of 20. And we have this here. Then we want to create for x and y random new values that got created like here. So we can basically copy and paste it and bring width and height and take the width and height values again. This pushed everything, which is not good, but matter. So we have the same here and there. This SC is still the create assigned, which is, I don't know why. But first we're gonna do this, and then I guess it's gonna. Let me just copy this here. That's again. Not so pretty. I don't know why. Probably, yeah. Like this, drag it up again. Now we have both the random functions. I would also make it a bit wider here, so I can move the z over. That makes it clearer. And now I put this here so we don't have too many spaghetti. But what we now take is like the width value for the x, take the negated one and non-negative one, then we take the height and assign it there. And then this is that. So we have now assigned the new x and y values when the z value is smaller than 1. Now we only need to assign pz. So we take pz, create a new input for the region, then hit escape so we don't make any connection, and then we have to make another reference of pz, and we can basically connect it like this but take the same value. So you couldn't just take this and connect it with pz because we plugged it here as an input. It needs the output with the same index value 3 here. Otherwise, it doesn't get assigned properly. So this now is the update function. So we have all this functionality. We can again hit Alt and drag and write update. And as a test, we already can check out if that works. So what we want is basically create, I wouldn't start with 25,000, but start with 1,000 and create 1,000 stars. So what we have to do is we write create and then click on this create operation. And because there are like already so many create operations for other classes, we have to look for our star classes, for our star class, which is here. You can click on star, and then we have the create operation that we defined, and we have the properties for width and height. So what we can do now, because we want to do that 1,000 times, we do right click and surround it with a repeat, and here we can define the iteration count. So we do left click, middle click to expose it, and write 1,000. So now we have to, here you see now every frame a new star gets created. You can see that by like the identity, which changes every frame. So that means it gets overwritten all the time. What we now have to do is we have to store them like they do here into a list of stars. In VVV and VL, which is the language, we use spreads, which is a collection like a list. So what we have to do now is we take the output, the star object, go to insert a splicer. And now if we click this, we see we have 1,000 objects, but still the identities get written over. So what we have to do, we have to store it into a pad, which in this case, we call it stars. And now we can connect it, and VVV knows directly, okay, it's a spread of star objects. And what we see already is if you look at the PZ, or we can close this. So we still have the same behavior. Why? Because if you look, we still run this creation, the repeat loop, on the update function, but it needs to run on the create operation. So when the sketch gets started, the create gets called. So we do right click, assign create, and now we see we have fixed identities because not every frame doesn't get a new object created, or 1,000 objects. So we basically achieved this setup, which is already good. Now we have to define the width and the height. We use for width 8 and for height 5. And now we want to, because we created in the star, now we want to apply the update, so the calculation with the speed here. So what we're going to do is we create a connection, double click left, or no, we create a for each region because we want to apply the update method like here. In VVV and VL language, we don't have, or we use basically, or we use most of the time for each instead of force. There are ways to create similar behavior, but use most of the time for each, and have then other operations to define which elements shouldn't be used. But yeah, so now we have the for each region, and for each element we want to apply update, or we want to run the update function. So we type update. Again, we have the same situation, a whole list. So we can type in star. And then we have the update function of our star. So now we take the output of the spread that we have, use it as a click on the first bar to insert a splicer, which splices up the spread in. So we have just one object here in the for each and connected. And then we can again connect it out with a back to splicer. Don't Not in the accumulator, that's a different behavior. Click on the splicer, and now we have to store the changes back again into the stars, otherwise they don't get applied. So we again look in our node browser for stars, and what we see now is, first of all, we don't see anything, but we will, because now we see the values are still, we see here and after and before it's still the same values, but the problem is obviously because we haven't applied any speed. And if we change the speed, we see that the Z position actually gets less and less and less. And if it's smaller than 1, it jumps back to 20. So that is already promising. So the only thing that is missing now is the show function, no? So we now can do the show function, and we start with creating this calculation. So we take the map node, which basically does the same as the map function. We reference x and z to the division, not 7, division, then plug it as the input into the map function. We see this here, but as you see, this now runs on the update function, as you could see with if you hover over the input, but we want to run it or update operations, but we want to run it on the show operation. So what we can do is either click here and create the new show, or we right click on the node, go to assign and click on new operation, write show, and we have it assigned to a new operation, and then can do the calculations that we want to do. So we divide x with z, minimum and maximum 0 to 1, and then 0 minimum and maximum width. So we take the width and reference it here. Then we can basically copy and paste it and do the same calculation here for y. So we calculate y divided by z, and instead of the width, take the height. In our case, we don't need the r because we don't want to show the ellipses. This is just for the radius of the ellipse. And because we create a line which needs 2 position values from basically, so px py is from and zx zy is 2. So we create the px py, and we can do that really simply by copy and pasting again. Whoa, do hello of clicking, drag it over, and here we want to do x divided by not z, but PZ and y divided by PZ, and we have 0 and 1 width and height. And then we want to assign to PZ the x value that we had lastly calculated in the update function. So what we do now is we drag or we reference PZ, have it here, and then we drag the Z from the update to the PZ, and this gives us first the error. This link writes to a pad that also another link writes to, because this happens here, but it is still the update operation. So we do right click, assign, right click, assign on the, and click on show, and then that problem is solved. And at the end, we want to, because we are running in 2D, what we see here, there's no WebGL reference. Normally for 3D and P5, you would reference WebGL. So we also do it in 2D. So what we want is we want to use the 2D render engine, which is vl.skier, that comes with VVV, the graphics rendering library. Use that, and then we go back inside our star with middle click, and we want to use a line. So we type in line, and there we have it. Graphics skier layers draws a line between 2 points. Now we need to join them because the line expects point A as a vector2 data type. So we type in vector or vec, and then we click on join, and then we need to decide which type. And we just have x and y, so we use vector2. We would use x, y, z, it's vector3 and more. And we already have the first point. Then we can select it, copy it, do the same, and use it as a second point. Now we still have to define that we want to the stroke and the color and the width, which is fine, okay, for now. And lastly, we want to create an output that we then can show in our main page. So we hold down Control, click left, and then we get a weird behavior. But we can just do right click on it, assign, create. Nope. Assign, show. So I guess it's this one, and that should have fixed it. And yeah, we can see what we get. So we have this speed value. That looks good. So after this, we need another for each region because we want to show the line for each object. So for each, no, this one. And then we can type in show again, left click, and there we see, because there is just a star object or star class that has the show operation. So we get it directly. We click on the lower output of the stars, spread, again go via the splicer, connect it, but this time because we don't want to change any data of the object, we don't want to output this, and we just want to output the layers and group them. So we click on the output with a layer, click on splicer, and now we need, because we need to group them all together from the spread, so we use a group spectral, and here we select the skier library. So VVV knows which group we want, and now we can type in renderer, connect the group, And we start to restart the sketch, and we have the basic behavior, which is kind of like this. So, but ours is obviously slower. We have less. But if we raise the speed, we get similar behavior. Woohoo! So what we can do now is we can increase the iterations, but this just gets applied if we restart the sketch. So now we have more. And yeah, we can close this down. And because this one is interactive with the mouse, so we also can do left click, type in mouse, and then click on Skia input output IO. And in Skia, the mouse needs to be grouped together with, but not spectral, this normal group, which connects different layers. We can drag this out, then click on the context, which is also a layer data type, and then we connect it. And what we then see is like if our mouse is over the sketch or the window, we get different position in the world. And this we can map to change the speed. So we use the map. We have values from, let's make that bigger. What we can do is we can use time bounds, add with control plus a new input to the group, and also connect this. So we actually get the size or the width and the height of the viewport, and then we can use that to map it. So if we do left click and middle click, we see the vector 2. So we want to split that. Vector 2 split. Now we have the width and the height, and we can now take the x, divide it by 2. Maybe we don't need the split. Yeah. Divide it both by 2. And use the positive and the negative. So we use the negate again. That should work. And then we want to map that to the speed. Yeah, no, that's not smart. Sorry. So we just want the x value. So what we do is actually, we take this, we do vector to split. Exactly, wait, what? Yeah, vector to split. So we only have the x value. We disconnect this. Oh, connect the x value with the map. And now this is going to be not nice. So now we can take this value, divide it again by 2. So we get half of it, take the negative and the positive. So we have yeah, divided by 2. And then we want to map that to, I mean, they're using 50, so we also can use 0 to 50. Maybe Yeah, that's not the right one because I'm not using the mouse. So we connect the mouse here. Now we have the mouse X, and we want to map that, but we don't get what we want. I don't know why. Let's see. So if we have a normal speed, this is all. Why is this all gone? Okay, this works. I get a value that's not available. So let's see. I have the client bounds needs to be connected with the group, and the mouse also needs to be connected. And now we actually have a changing value. So that should now solve it, but it gets really fast. It gets so fast that you don't see anything. So we lower this even more. We also want to probably change how far away they are. So it definitely struggles with the create function. So yeah, this is at least for now. I'm right now not sure why this is a problem. We run this an update. It should be right. I guess it has a. What we can do is. Yeah, I think that's okay for now. Next time we're gonna make it more interactive, but maybe we can do some fun and apply some effects. So we can use the Stride texture FX package, which allows us to apply interesting effects. So now we first want to translate from Stride to texture FX. So we're from Skia to Stride. So we can type in to texture from texture, image to texture. We can use Skia texture, I mean. So we take the group layer, right, Skia texture, and now we have actually texture. And this converts it into the texture of X land. And to show this as a window, we can type in texture window. And now we get a new window and we see the same. We can close this window and now we have this. I'll stop this for a second. and we show our texture window. And now we can create interesting effects. Like we can type in Shift RGB, which is part of the stride texture filter. Click it, just connect the skier texture with it, connect it with texture window, and now we already have like an interesting effect. So we can apply a little bit of Shift, RGB, Shift, and we can try another polar to Cartesian. This is obviously now really just experimental, but there's a lot to play with. Also, another point is obviously we can create a feedback loop similar to what we have often in Touch Designer. So we use a feedback and a blend to blend the normal texture together with the feedback texture. We use the output to source it back again in the feedback loop. And then we can decide what we want to use. And already we have average, and we see we get a really star like stripy one without changing the speed. But this is a classic feedback loop, which then obviously gives us a lot of options. We can transform it and scale it maybe. So what we want is here. We want, maybe we don't find it there. So we go into stride, filter, and then type NTR for transform. And now we can apply transform matrix and use scale, transform 2D. And now if we're scaling, we create interesting effects. Add a rotate. Yeah, okay, I don't want to get carried away. I just wanted to show you how that could be done and why that is really interesting. Yeah, VVV is super powerful, 2D, 3D, particle systems with other packages. But yeah, you can basically use the same object-oriented programming. It's a little bit different, but yeah, I wanted to show it, how you could apply it. And yeah, I want to say thank you. I hope that was useful. If not, or just write in the comments what I should improve, if I should do more. I thought about doing all the coding challenges so I can learn a lot of new techniques and I can share it, and other people can learn new techniques, and the knowledge base for VVV is growing. Let me know. Have a great day. Thank you. Goodbye.